Today is 2122. I don't know why. I want this little fella. Oh, that's pretty good. Yeah, 2122, and the name of these notes, I don't actually know if I named them earlier today. Sorry for the handwriting there. It'll get better, I promise. I think we'll just call this solving log equations. Now, this is not a one-day endeavor. Solving logarithmic equations is theoretically a several-week endeavor. So there's lots of different flavors of these. What you see today is just sort of a piece of it. So again, don't think that we just kind of one and done this. Anyhow, just be aware that these notes are not going to be done when we're done here today. So before we can actually get into solving log equations, I now know from first hour that I should make sure that you have some base knowledge before we dive in, because without it, we're not going to go very far. So I'm going to put a math problem up here, and I'm going to see how you do. And as is always the case, if like 6 of you know the answer, that's not good enough. We should all know what this means. We know how to translate this in our mind, right? 81 to the power of 1/2 is another way to say what? Couldn't have said it better myself, Carlisle. The square root of 81. So we remember that the fractional exponent, each number serves a role, a purpose, and the 2 serves a purpose of becoming an index. Start using that word, the index of a root, right? And then the 81 gets the power of 1. And you'll see today, it actually is going to be beneficial for us. Instead of putting the 1 where you're used to, I'm going to write this in yellow real quick. You're used to this, I think. Today, you'll see it actually serves a beneficial purpose for us to not put the power, the top of the fraction, inside. Mark my words, we're going to be better off if we put it outside. Now, I will say, neither of the numbers in the red and yellow problem would I actually write in practice. They're both pointless, right? 81 to the 1, who cares? The second root, we know it's there whether we put it or not. So in reality, again, going back to what Carlisle said, if I gave you 81 to the power of 1/2, you would understand that it's just the second root of 81, also known as 9, right? Some base knowledge there. Let's try this one. 125 to the negative 1/3.
25. There used to be, but it would be
1/5.
It would be 1/5. So there's a couple of components at play here, and now we have 2 things to consider. The first thing to consider is, again, going back to what a fractional exponent means. And I'm going to highlight a number for you here with a little red circle. Again, what is that number?
3.
Sorry, I know. Yeah, thank you. It's an index. It tells us the type of root we're going to be using. So we know we're using a third root or a cube root of 125. And what does this yellow negative tell us? That it's going to go flipperooski to the bottom, right? We learned that the other day. It was a very short sort of passive thing, but we learned that a negative exponent just flips, causes things to fraction down. So I think about this in 2 phases. I say phase 1, I'm going to take the third root of 125, which is 5. And because it's a negative, I'm going to put it underneath the 1 in the bottom of a fraction like that. So 2 sort of thought processes at play there. We okay so far? All right. Next one up is going to be 64 to the 4/3. Placement of the numbers is critical. I didn't show any work on the second problem because I didn't really think it deserved it, but this one I am going to. And even if you know the answer already, please don't say it out loud, because it kind of, as a kid, kids hear you say the answer and they go, oh, I'm not going to think now because it's already done. So if you think you know it, just hold it, tuck it, and we'll see how you did. But I'm going to assign the numbers in the exponent to their homes, like to their posts, right? And so I'm going to take the 64 and I'm going to put it inside of a root. I'm not going to leave it, though, as a square root. The bottom of the fraction is going to indicate to me, the index tells me it's a 3, it's a cube root. And then the top of the fraction, the 4, is going to be a power, and I'm not going to put it on the 64. I'm going to put it, I elect to put it outside the root. The reason is, I don't know about you, but I don't want to deal with 64 to the 4th power. I'd rather take the cube root of 64 first and then raise that answer to the 4th power. And they do come out the same either way. It's kind of a nice little thing. Okay, so again, you got to know where everybody goes, where their posts are. So now a couple of quick questions, which both of which you should know by this point. What is the cube root of 64? That is 4. And what is 4 raised to the 4th power? It is 256. And that's going to be, did you guys all get a copy of the powers table from Delaney? That's going to come in really handy as you go through these. The handiest thing in the world is to know things like the cube root of 64, 4 to the 4th power, 3 to the 5th power, 2 to the 6th power. The quicker you just know those rote memorization, then you'll be less bogged down. But that's how that one would go. Okay, let's try another one. Let's do 512. And his exponent is -2/3. And again, not a race, not a mental math prowess contest. Let's give everyone a chance to let that simmer. Anyone willing to volunteer an answer? I think we've had enough time. Xavier?
164.
That is correct. It's 1/64. So let's take a look at how that comes into existence, okay? It's just, you got to understand, again, each number, each little guy in the problem has a role to play. The negative says, I'm going to flip your 512 downstairs. The 2 says, I'm going to eventually be an exponent on something. And the 3 says, I'm going to be a cube root. Everyone just kind of goes to their job posts and then says, let's go. So here we go. We're going to take the 512 and we're going to put it inside of a root sign. And then I'm going to decide that the flavor of my root, courtesy of that 3, is you're going to be a cube root. And then I understand that the 2 serves the purpose of saying, when you're done screwing around with that root, why don't you raise up to me as a power? And then finally, the negative says, why don't you just do all this nonsense you're doing, only do it at the bottom of a fraction? Because that's what I say. Again, everyone serves a role, a purpose. And from there, it ought to be light work for you. And again, with the benefit of your table and maybe just some memorization, you should know what is the cube root of 512. It is not. The cube root of 729 is 9. The cube root of 512 is 8. So the answer to the root part is 8. And then we use the yellow exponent. 8 squared is 64, leading to the answer, like Xavier said, 1/64. Okay. Don't worry, you're going to have lots more chances to practice. I'm just doing this, re-recording this in a different order because first hour, I taught this kind of when the time came. This time I'm going to try a little different. With you guys, I'm going to run some advanced interference and say, here are the requisite skills so that when we get to the problems, the actual notes, then you go, I know what to do. So now I'm going to run through a series of very, very quick questions. I have these first 6 problems labeled as, and I quote, easy. So these should take approximately, they take longer to write down than they do to actually do. You're going to have your first set of Delta math questions. 15 of them ought to take you, I'm not exaggerating, like 2 minutes to do 15 problems. So you're going to be faced with just these. These are kind of like our warm-ups. two ways to struggle with these. Number one, you still don't know your basic facts. And number two, you don't understand how logarithms work. Those would be big deal breakers for this assignment. What this problem is saying to us is if we embrace that little water cycle diagram, it's saying x to the power of 6 equals 64. It's a fine art there, the ability to convert to logarithmic and exponential and vice versa. Clearly, we know this one. What number do you have to raise to the 6th power to get 64? So the answer to this equation is 2. Done. Okay, and I'm not going to show as much work next time. I'm going to maybe go a little quicker. This one is log base 2 of 128 equals x. The question behind the scenes is 2 raised to what power equals 128? Use your table. The answer is 7. So x equals 7 for this one. You see what I mean, how these are going to go relatively quick. And there's no trickeration in this first batch. How about this one? Log base 9 of 81 equals x. Are you kidding me? Mm-hmm. The answer is 2. And again, if you don't know that one, it's not because you don't know 9 squared is 81. It's because you still aren't fundamentally embracing that relationship, the little water cycle diagram. This to this equals this. It's not the math that would get you in a problem like that. It's do you understand the logs? Next one, log base 3 of x equals 2. 9, good. You understand that it's 3 to the 2th, which is 9. How about log base 8 of 512 equals x? 3, right? We're looking for the exponent. And then finally, before we get to the good ones, log base 4 of x equals 3. 64. So that's, I say 2 minutes might even be, maybe a minute, honestly. Probably take you longer to click submit and then to verify, yes, I want to submit box. But that's what the first section of problems is. And then we get to, can I scroll up yet? Okay. You sure? Okay. And then these I have labeled as harder. I didn't put hard, I just put harder because relative to that, they're a little tougher. So our first one for our notes is going to be log base 100 of x equals 1/2. And again, let's pump the brakes if you're one of those speed demons who likes to say it first. Let's not race each other. You understand that buried in here, there's really just a simple math problem, right? It's saying, embrace the little water cycle diagram. It's saying 100 to the power of 1/2 equals the answer you're looking for. 100 to the power of 1/2. We started class with this. Tanner, what is 100 to the 1/2 power? It would just be 10. Done. Final answer. Because remember, the 1/2 power is another way of saying the square root. Okay. Next one. Log base 64 of x equals 4/3. This is going to look very familiar. It's actually one of the warm-up problems we did. You just don't maybe know it yet, but it's there. This is the 256 that we saw like 8 minutes ago, because again, I'm not looking to fill in a blank anywhere other than the quote unquote answer, right? I'm just doing 64 to the power of 4/3. And if you were to look back in your notes, like I said, that was very, very early in our notes. Cube root of 64 is 4. 4 to the 4th power is 256. Okay. Next one is going to be log base x of 1/81 equals -2/3. This was the point where I knew that I would slow down. So just kind of be advised, we don't cruise control our way through a problem like this. Not most of us. And if you're just sitting there staring at a calculator, you probably want to tone that down a notch. This is really about a process. This is about embracing a process. So my first pro tip to you, and you should take it, advice, you should always take teacher kind of advice, is to take it and write it as an equation. I didn't need to do that for the last few problems. Those are easy. Those last two, they were a joke. But this time I'm going to actually make an equation, and it's going to, again, be me embracing the little blue arrow diagram. What would it say if I just took it out and wrote it without the word log? Anyone know? Xavier, what would my equation say? You know, thank you for answering that so efficiently and perfectly. That's exactly the equation that you need to put in your notes, because that is what the equation looks like if you do the conversion from what we call logarithmic to what we call exponential. Now, I have something I'm going to show you. Xavier has something he wants to say, but I'm going to first show you the way you need to solve an equation like this until you can start doing things like this in your head. And this is honestly like maybe the only bit of little trickeration black magic that I'm going to show you today. My goal is basically to make that exponent go away, that exponent in the yellow box. Because if you think about it, if I could turn that exponent into a 1, I would be done. Because what I'm trying to figure out is x equals what? And if it says x to the 1 equals, it's game over, because x to the 1 is the same as x. And back in like 5th, 6th, 7th grade, you learned that if your teacher gives you a fraction like -2/3 and wants you to multiply it by another fraction to get the answer of 1. There's a name for those things that we multiply together. They're called reciprocals. And you know that when you multiply a fraction by its reciprocal, all the stuff cancels out. 2 negatives cancel, the 2's cancel, the 3's cancel, the whole shebang. Because if I multiply by the reciprocal, we go cancel, 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 presto 1. So the idea here is I apply that 6th grade knowledge to a high school math problem and think, okay, dude in the yellow box, your time is limited here. I'm going to take you and raise you to the power of your reciprocal. Because by doing that, I know my rules of exponents say that I should multiply those two exponents together. Even though it's a power to a power, I know the rule says to multiply. And of course, fair is fair. We learned this years ago that if I raise the left side to a power, I must also equally raise the right side to the same power. That's the trickeration. That's the trick. And I'm almost done, Xavier, and then I promise I'm going to get to you because I know you got something that's just so on your mind. It's probably going to blow everyone's mind, huh? You know it is, but hold on to it. Savor the flavor. I'll be right back with you. Give me like 39 more seconds. Don't count. So on the left side, my exponent in the yellow box and my new red exponent are effectively going to cancel each other out, leaving me with the end of the algebra problem, x equals. And this again goes back to the beginning of class today where we learned how to do this kind of math. What will the negative exponent do to my blue number? It will flip it. And you're not used to this. You're used to taking a number like 81 and saying, oh, I'm going to put you on the bottom. Well, what do you think we do if it's already on the bottom? You put it back up to the top. So really what's happening here is this blue and red mess over on the right is actually the same as a flipped 81 back up to the power of 3/2. Acknowledge and respect that negative exponent. That's all he does. Negative exponents are stupid and boring. They just take things and make them go down and make them go up like a freaking elevator. And now we got to do the math. In order, we should do the math, and we should always do it in this order. What is the second root of 81? And what is 9 to the power of 3? Our answer then to this equation is x equals 729. That is not light work. That was a math problem. Xavier, would you still like to share this knowledge bomb you're about to drop? Do I need to pause my recording? Like, is the room going to explode?
No, probably not. So all you have to do, the x and the 1/81, and just take the reciprocal of the 3.
Yeah. That's effectively just what we did, right? I know you like to look for shortcuts, don't you?
Yeah.
For the rest of us with that short. Yes, of course. You could do 50 of these in a row and you will eventually arrive at that conclusion that yes, there are always shortcuts. But I think the shortcuts can be a little confusing when we're first learning. So the process is what it is, and that is to kill the exponent and then do the same thing to the other side that you had to do to kill it and then do the math. And that's that. You got another one and more knowledge for us, Xavier? You're going to drop another bomb?
Well,
I'm gonna write the next problem down while Xavier's dropping his knowledge bomb here. So
What if none of the, what if all the numbers were?
we're not going to give you problems like that. And when eventually we do, we're going to start really heavily embracing the calculators and the decimals and all that kind of stuff. For now, all these numbers are going to be pretty beautiful. We're learning the process. What's the equation going to say? Just the equation, not the answer, just the equation. This to the this equals this. What's it going to say?
X to the power of -2 equals 1.
Good. And I gotta be honest, I don't really think necessarily that this deserves the process that we used on the last problem. This is not a process problem. This is just a get your head out of your booty and think about a problem. What number do you have to raise to the power of -2 to get 1/25? 5. So the answer is simply 5. No process there, no steps, just thinking. I have one more example and then I'm turning it over to you for work time. And my last example is this. Log base x of 1/729 equals -6/5. All right, now you know what I'm going to ask you to do. And just don't give me an answer. It's write an equation. I want an equation. Hayden, can you give me my equation?
X to the power of -6 729.
Thank you for so perfectly doing exactly what I asked you to do. Thank you. No math, no trying to whiz me with your mad skills. Just there it is, converted this to the this equals this. Well played, sir. This definitely deserves our respect, right? Not you, Xavier, you little shortcutter. The rest of us, what are we going to raise the left side up to? What power is that going to be?
-5.
Yeah, we're going to raise it up to the power of -5/6. And I don't want to get yelled at by my 7th grade math teacher. So I know, oh, that's right. If I do it to one side, I got to do it to the other side. Good.
You were my 7th grade math teacher.
I know I never taught you 7th grade math.
No.
Anyhow, we understand that the exponents on the left side now, by doing what we did, will cancel, leaving us with x equals. So the algebra nature, the algebra aspect of this problem is done. Now I got to do some math. And again, these are questions that you need to answer on your own once I'm done talking to you. What is the negative exponent going to do? What's his one purpose in life? He's going to flip. He's going to flip a bottom heavy to a top heavy. He's going to flip a top heavy to a bottom heavy. There's one or the other. It's like binary, this or this, right? And so if the 729 is currently a bottom dweller, the negative exponent is going to make him a top dweller. So we're going to turn that into a normal 729 to the power of 5/6. Not yet, Xavier. Got it? Now, do I think for a moment that we wouldn't use a calculator? I'd sure like to think so. Like things like that make me smile and feel warm and fuzzy, but this one will get a little nasty. But your Delaney-McDonald table will help you, because think about what this is now. This is asking me to figure out, okay, so x is going to be some number, a 6th root of some number raised to the 5th power. So if you were to, here's a challenge for you. Look on your Delaney-McDonald table, because you're not getting through this one, I don't think, without it. Find me a number in what column. There's like the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In what set or column of numbers will you find something that has a 6th power equal to 729? The power of 3 raised to what power? Nice. So here's what that means for me. If I understand how to interpret that table, that means what I have here in this red bubble, you ready for this? Just equals 3. Huh. And then when I raise that to the 5th power, I'm going to go back to the same table again. What's 3 to the 5th power? The answer then is 243. Sweet, huh? Some processes or some problems deserve a process. Some problems we just knock them out. Yeah. I'm going to stop the recording. Is that? Then it's undefined because you can't. A logarithm by nature has a restricted domain of non-negative arguments. Oh, and negative bases also. Yeah, I don't think you're going to see any negative log bases. I never have.